So the next video I want to do is on the multivariate delta method. And similar to the multivariate CLT video, I want to start by writing out what the single univariate delta method is. So the delta method is, we have that square root of n of yn minus mu converges in distribution to a normal distribution with mean 0, variance sigma squared. Note that yn is a sequence of random variables. Right? Then, for a function, g of x, let's call it, such that g of x is differentiable and the derivative of this function evaluated at mu is not equal to 0, we have, this is only true if these two conditions are true, but we have that square root of n g of y sub n minus g of mu, right? So we have yn becomes g of yn, mu becomes g of mu. Converges in distribution to normal distribution with mean 0. Variance is, instead of sigma squared, it's g prime of mu all squared, sigma squared. So now, to extend this to the multivariate delta method. We have, for the multivariate delta method, that square root of n times yn minus mu converges in distribution to normal, multivariate normal, with mean vector 0 and covariance matrix sigma. Note that yn is, instead of a sequence of random variables, it's a sequence random vectors, right? And mu is a sequence of, it's not random, let me write that again. Mu is a vector of the means of each component of yn. So it's going to look like mu1, mu2 to mu k, let's call it. Then we have, for a function g, right? So g is going to be a function that goes from, it takes in k inputs and gets out a 1 output, right? And we have, just by definition, the gradient of g at y is equal to partial of g, partial of y1 up to partial of g, partial of yk. It's just what a gradient is. Let's define, or say gradients of mu is g of y at y equals mu, right? Also, each component of this gradient have to be non-zero. finally, we have that the square root of n of g of yn minus g of mu converges in distribution to a normal distribution with mean 0, and variance is the gradient of mu transpose times sigma, or sigma gradient of mu. Note, I'm kind of running out of space, but gradient of mu transpose is going to be a 1 by k matrix, right? Sigma is a k by k matrix because we have k entries in each vector. And gradient of mu is k by 1. So if you take this, there we go. That's going to be 1 by k, k by k, k by 1, which is going to get us a 1 by 1.